Welcome back, aspiring physicists. Today is an exciting day because it is one of the first days that we get to do a little bit of math together. And I think that's just it's going to be so fun, you guys. I can't wait. You guys are going to have such a great time. I'm going to have a great time. We're all going to learn a lot. It's going to be all around a 10 out of 10 time. So what we're going to talk about today is unit analysis and unit conversions. This, if you have had chemistry before, I believe is a review for you, but chemistry is not a prerequisite for this class. So I'm going to go ahead and just teach it to you anyway, especially because if you are going to college for something like engineering or chemistry or medical school or really anything sciencey at all, this is going to be a topic that's going to come up a lot, and you're going to kind of need to know the basics of it. So it doesn't hurt to see it again, even if you think you're a master at it from your other classes. So, never hurts to practice. So we're going to talk about how to analyze units and how to convert units. Don't get used to this business. I've just been feeling like especially productive the last couple days. So you're not going to get a nice pretty picture every single time, but I have the time. Look at this tree, you guys. Check this thing out. Do you see this tree right here? I'm super proud of this. Look at the shading. Look at the depth of this thing. What a sweet tree. If we really wanted to spruce it up a little, check this out. Watch this. We could put like a little, how do you say, like a... There, look at that. Sweet. Put a little knot in it. How tight is that tree? Anyway, let's go analyze some units and learn to convert. So, before we dive into it, right, let me give you some pointers ahead of time, tell you a couple rules about things, and then we'll do some examples together just to get your feet wet, help you slip into the pool of physics gently, and get acclimated to the water. So, first thing we need to know about how math works with units is it's not possible to add different units together. Meaning you can't take 5 meters and add 7 seconds to it, because 5 meters, this thing is measuring a length, and the 7 seconds, this is measuring a time. You can't add lengths and times together. They're not the same thing. So if we have two things that do not have the same units, you're not allowed to add them together. It's like taking a dog. What do dogs look like? Something like this. Oh, no, that's a mouse. Sorry, I messed up. Anyway, it's like taking oranges and apples. If you put them in the same basket together, they don't all turn into like some kind of apple with a thick citrusy peel, right? They're still oranges and apples, separate, distinguishable things. You can't add them together. You can, however, multiply them together. So if we multiply two units together, and this is in quotes because it's not like a nice term. This is not good math, right? It sticks units together, and you can add exponents to units, etc. So if you have a meter times a meter, you're going to get meters squared. If you have like a mass times an acceleration, you can add kilograms, or you can multiply kilograms and meters per second squared and get kilogram meters per second squared. You can multiply things together. And it kind of works like multiplying variables. If you have x times y, you get xy, right? So if you have kilograms times meters per second squared, you just get kilograms meters per second squared. It just mushes them together or sticks them together. Okay? You can also divide units. So if you have meters squared divided by meters, this 1 meter cancels one of those and you have just meters left, right? Meters squared over meters. That one cancels one of those and you get just meters. If you had like meters squared seconds over meters seconds to the third, right? This cancels one of those and we have a meters on the top. We have 1 second on the top, so it'll cancel one of the bottom and you'll have 2 left on the bottom. So multiplying and dividing units works very similar to the way multiplying and dividing variables works. You just stick them together or cancel exponents based on how many there are. Okay. And because we can multiply things, you can also do exponents the same way, because exponents are just repeated multiplication. So if you have like a meters squared to the third, that's just meter squared times meter squared times meter squared 3 times. So when you multiply, you just add the exponent. So you get meters to the 6th. This doesn't really mean anything. It's just an example. But because we can multiply, we can do exponents. Okay? So if you multiply meters times seconds, you get meter seconds. This is janky. That might be something else. But if you have kilograms divided by kilograms squared, this cancels that, and you have just per kilogram, right? So it works like variables. All right. So let's go ahead and find the units for some of these things. Here are some equations. I'm going to go ahead and give us the units, and we're going to try and figure out what are the units of the answer. So this is distance, and we use x for that, but we'll get to that later. Don't trip too much. Distance equals velocity times time. So the units for velocity are meters per second. The units for time are second. So we're going to do meters over seconds times seconds. When we multiply, you multiply the tops together. So meters times seconds is meters seconds. And then seconds times 1 is seconds. The seconds cancel, and we get just meters. Okay. This is the equation for volume. So we want to know, what are the units of volume? What do I measure volumes of things in? So if you want to find the volume of something, I believe this is for like a box, right? That's an ugly box. Yeah. Oh my God, I can do better than that. No, I can't. There we go. So if we want to find the volume of a box, it's the length of the box times the width of the box times the height of the box. So we're going to replace the variables with their units. So the length, we measure length in meters. We measure width, that's just a different length, so still in meters. And we measure height, that's still a length, in meters. So this is meters times meters times meters. That can be written as meters cubed. So our volume would be measured in meters cubed. All right. This is the equation for density. So the equation for density is mass divided by volume. So mass we measure in kilograms. Volume we measure in meters cubed. So the units for density, you just replace the variable with its unit. Density would be measured in kilograms over meters cubed. Cool. All right. You're going to have a couple problems like this. I'm going to give you the units of things. Instead of giving you full-blown equations like this, I might give you something like x equals meters squared times seconds squared divided by meters seconds to the third. And I'd ask you to just simplify the units. That's what your homework's going to look like. So if you're going, Mr. Bourne, I have no idea what these equations are or where you're getting these units from, don't worry about it. You're going to be given the units on your homework. You just have to make sure that you can simplify them like this and like this. Okay. All right, so that's kind of how we're going to stick units together. This process is called unit analysis. We will use this just to check that our equations are set up correctly. Later, we'll use this to try and kind of figure out what units things are made of, things like that. Yeah, so all right, let's go ahead and talk about unit conversions. So to convert units, if I ask you how tall you are and you say you're 5 foot 10 inches, and then the doctor says, no, but in metric, how tall are you? 170 centimeters. We need to know, how do I get from this to this? So that's what we're going to learn. We're going to learn to convert one type of unit into another type of unit by doing some math. So to convert units, multiply the original unit by a conversion factor or ratio to cancel out the old units and leave the new ones. Some conversion factors you're already going to know. For example, there are 60 seconds in 1 minute. Things like that I'm going to expect you to know, most of the time ones. But then there are going to be some that you're either going to have to look up or I'll have to give them to you. So for example, 1 inch is 2.54 centimeters. I don't expect you to know this. Most people don't have metric conversion rates just memorized. So if you need them for a homework problem, I'll give them to you. Okay. So what we're going to try and do is we're going to try and set up some ratios, which is a fancy math word for fractions, that are going to cancel out all the units, and then they're going to leave us with whatever unit we're looking for. Okay. So let's talk about an easy one-step conversion. Just to show you how it works, to show you how to set things up, and how to simplify your fractions. So we want to convert 6 feet into inches, right? You walk into the doctor's office, they say, how tall are you? You say, I'm 6 feet tall. And they say, I'm sorry, my computer needs it in inches. Do you know how tall that is, right? I think that's a real thing they do at like the blood bank. If you go donate blood, they always write down your height in inches, not in feet. But so to do this problem, we have to know that 1 foot equals 12 inches. This one you probably should know just because I don't know. I think this is like a 4th grade learning standard in your math class, but anyway. So here's how we're going to set up the problem. Most of you can see, okay, I need to just take 6 and times 12. But this is only going to get you so far. Like having this intuitive, I need to do 6 times 12, and the answer is 72 inches. This is fine, but when you get to more complicated things like multi-step conversions, going from 45 miles per hour into meters per second, it becomes less obvious that you just multiply. Sometimes you're going to have to divide. So let's talk about how should I set this up and how do I go about simplifying it. So you want to start with whatever you know at the beginning. What are you converting from? What's the initial thing that they give you? And you're going to write that down with the units attached to the number. So we're going to write down 6 feet. Then we're going to take our original number or unit or whatever value they give us, and we're going to multiply it by our conversion factor or our conversion ratio. And we're going to set up a fraction using these two things. when you set up your fraction, what you want is you want the unit you start with to get canceled with half of the fraction. So because we're starting with feet and feet is on the top of this fraction, the 1 foot part needs to go on the bottom so that this feet here cancels with this feet here. That means the 12 inches has to go on the top. So when we look at this, we're going to have 6 times 12, just like we knew intuitively up here. And we can see feet cancels with feet. One thing on the top cancels one thing on the bottom. The number 1 doesn't have units, and then the 12 has inches left on top. So when we multiply, 6 times 12 is 72. Bring over our units from the top, which are inches, over 1 times 1 is 1, and all the units are gone, so it's just 1, which is 72 inches. So start with your original number or value that you're given. Multiply by your conversion rate as a fraction. Make sure that whatever you want to go away cancels out with the thing you started with. All right, let's look at this 2-step conversion just to kind of drive home how we set up these ratios and how everything's going to cancel. And then we'll do a multi-step one just to really beat it to death. So if I said convert 7 hours into seconds, most of you will probably go, okay, well, it's 7 and in an hour there's 60 minutes. So I need to multiply to get how many minutes there are. Then in 1 minute there's 60 seconds. So I need to multiply to get how many seconds there are. So you can see that 7 times 60 times 60. But again, with these more complicated ones we're going to get to, you're going to need to understand how it works. Because again, sometimes you're gonna have like 7 times 1 over 60 to make the units work, and if you're just multiplying blindly, that's not always gonna work. So let's start by writing down our original unit. So we have 7 hours. Now, one of our conversion factors is 1 hour equals 60 minutes. So I'm gonna multiply. I'm gonna put the hours on the bottom so that it cancels with the hours on the top here. And I'm going to put the 60 minutes on the top. Then we need to multiply to get rid of the minutes. We don't want our answer in minutes, we want it in seconds. So we're going to multiply by another conversion factor. I want the minutes to cancel out. So the minutes part is going to go on the bottom, so that this bottom minutes cancels with this top minutes. And we're going to put 60 seconds on top. And the abbreviation for seconds is just lowercase s. So now we can see that hours cancels hours, minutes cancels minutes, and then we're left with just seconds. So seconds, and then you're going to take your 7 times 60 times 60 across the top, and just multiply that in your calculator, and we get 25,200 over 1 times 1 times 1 is 1. So there are 25,200 seconds in 7 hours, in case you were wondering. All right. Now we're going to do a multi-step conversion just to really drive home the point and look at something that's not quite as intuitive. And then we will talk about metric conversions. So we want to convert 45 miles per hour into meters per second. So first, let's look at this unit right here. Miles per hour. You may not know it right now, but this is implying a fraction. There are 45 miles. MI is the abbreviation for miles, per hour. That means per 1 hour. So over 1 hour. So what miles per hour is telling you is if you drive for 1 hour at this speed, you will travel 45 miles. Okay. So we want to convert that into meters per second. So our answer should be something like this. So we need to do two conversions here. We need to convert our miles into meters, and we need to convert our hour into seconds. So there's two conversions going on. So it doesn't matter what order you do them in. Multiplication is what's called commutative, meaning 2 times 3 is the same as 3 times 2. The order doesn't matter. So you can do either the time conversion first or the distance conversion first. It doesn't matter. We'll just start with the distance though. So I want to convert miles into meters. So we're going to multiply. Miles is on top here, so that means my miles should go on the bottom of the next fraction so that they cancel out. And we're going to put our meters on top. 1,610 meters. This is not exact. It's like 1,609 point something, but we're rounding just to make it a little nicer. Okay. So this fraction will take care of the miles to meters. Now we need to deal with our hours to seconds. So let's do that in red just so we can tell the difference. So here we have our hours on the bottom, and you're thinking, well, we just did hours to seconds here. It's just times 60 times 60. But this is why we're setting up the fractions very carefully and not just multiplying blindly. Because our hours is on the bottom, we need an hours on top to cancel it out. So this time, we're going to put the 1 hour on the top over the 60 minutes. So we can see here the minutes is on top and the hours is on bottom. In this problem, this is flipped and we're actually dividing by 60 instead of multiplying. So we can't just do it blindly. We have to be very careful and set up these fractions. So we've gone from hours to minutes. Now we need to go from minutes to seconds. So minutes is on the bottom. So we're going to do 1 minute on the top so that the minutes cancel. And we'll put our 60 seconds on the bottom. Okay. Now we want to go through and just make sure that everything cancels out. So our miles cancels miles. Our hour cancels hours. Our minutes cancels minutes. And let's look. On the top, we have meters left, and that's it. On the bottom, we have seconds left, and that's it. So it looks like our units are lining up the way they're supposed to. Now we go through and do the multiplication of top times top times top. So we're going to do 45 times 1,610, and we get 72,450. Then on the bottom, we're going to do 1 times 1 times 60 times 60, and we get 3,600. Then we're going to just go ahead and divide these two numbers. And in this class, I usually do answers to decimals of 2 places. Pardon me. Unless I say otherwise. Some problems, it makes more sense to do more places, but in this case, we'll just do 2 decimal places. So when we do this, we get 20.13 meters per second. You could also write this as just the number and then the units as a fraction at the end, 20.13 meters per second. This is kind of the nicer way that you're going to see it, but because we're setting up fractions, if you left it like this, that's fine. All right. So there's multi-step conversions. We can see why it's important to set up the fractions carefully instead of just multiplying intuitively, because sometimes you'll get the wrong answer that way. So the last thing we need to look at is how do we do metric conversions? And metric conversions are actually some of the easiest conversions, very intentionally. That's how the metric system is set up. I've got an interesting graphic we'll see in like a slide or two. So when we're doing metric conversions, we're going to follow the same procedure we just did for other unit conversions, but it shouldn't be quite as hard because of the way metric works. When you're doing metric conversions, it's helpful for you to ask yourself how many of the smaller units are in the bigger unit. So if you're going, for instance, from meters to kilometers, there are 1,000 meters in 1 kilometer. Likewise, if you're doing maybe meters to centimeters, instead of saying how many meters are in a centimeter, you want the smaller one into the bigger one. So there are 100 centimeters in 1 meter. One time when I was in college, I had a chemistry professor tell me, he asked me how to convert from centimeters to meters. I said, there's 100 centimeters in a meter. And he said, well, that's a really backwards way to think about it, but I guess. And I've never been so offended in my life. He told me that I should think about it as there being 0.01 meters in 1 centimeter, but I think that's dumb. I don't like decimals, so I think about it as smaller units in bigger units. But I'm not your mom. I'm not going to tell you how to live your units. So let's convert 3,600 meters into kilometers. So we're going to start by writing down the original unit or term that we're given. So we have 3,600 meters. Then we need to multiply by our conversion ratio. So we ask ourselves, how many of the smaller unit are in the bigger? There are 1,000 meters in 1 kilometer. And we have meters on the bottom here to cancel the meters here. Now, I know you guys are in an AP class, and I don't mean to insult your intelligence, but I'm going to just really quickly talk about how to quickly multiply and divide by 10, 100, 1,000, 10,000, anything that's 1 followed by some zeros. Here we're dividing by 1,000. So what that means is we're going to move the decimal of this equal to the number of zeros in the number. So because there are 3 zeros here, we're going to move the decimal 3 places. Because we're dividing, the number should get smaller, so the decimal is going to go to the left. So 3,600 divided by 1,000 just goes 1, 2, 3, and the answer is 3.6 kilometers because our meters cancel and we're left with kilometers. Okay. If we want to go from meters to centimeters, something smaller, we're going to say we have 18.2 meters. Sorry, let me put my pen on a diet. Times, there are 100 centimeters in a meter. And I'm just going off of this chart from yesterday. Here it is again, if you'd like to rewrite it down. But we can see here how many are in 1 meter. There are 100 centis in 1 base unit. So there's 100 centimeters in 1 meter. So we're going to multiply. We've got 1 meter on the bottom, so the meters cancel, and there are 100 centimeters in that. This time, because the 100 is on top, we're multiplying. So again, we're going to just move our decimal however many times equal to the number of zeros in the thing we're multiplying by. So because there are 2 zeros, we're going to move our decimal 2 places. So we go 1, and you go, oh, I ran out of numbers. Just throw a 0 on there. So there are 1,820 centimeters in 18.2 meters. Okay. Last one can be a little bit tricky, and I think we're going to get a really bogus answer, but that's okay. Sometimes life's a little bogus. So here, you probably don't know how many millimeters are in a kilometer. Okay. So in this case, it makes sense to make a pit stop at the base unit in the middle, meaning meters. So let's start by writing our given term. We have 3 millimeters. Now, we want to convert that to the base unit, the middle unit, meters. So, put our millimeters on the bottom because we want to cancel them out. So, how many millimeters are in 1 meter? There's 1,000. So, 1,000 millimeters in 1 meter. Then, this is going to convert us into meters. After we convert into meters, we need to do one more conversion to get all the way to kilometers. So now we're going to do one more multiplication. Put meters on the bottom to cancel with those meters and kilometers on the top. So now we ask ourselves, how many meters are in a kilometer? Well, there are 1,000. Okay. So our millimeters cancel millimeters. Our meters cancel meters, and we're left with kilometers. And now we need to divide by 1,000 twice. So we have 3. Here's our invisible decimal. By dividing by this 1,000, I need to move the decimal left 1, 2, 3 places. So we're going to go 1, let's add some zeros, 2, 3. Then I need to divide by 1,000 again. So we need to go left again 3 more places. So we're going to go 1, 2, 3. 1, 2, 3. So 3 millimeters in kilometers is 0.000003. This example is just to show you like the worst it could probably get as far as metric conversions go. Notice that when we are doing metric conversions, where we're just going from meters to centimeters, this works with liters to milliliters or grams to kilograms, any metric unit. What's nice about metric is everything is a multiple of 10, or a power of 10 rather. So it's either 10, 100, 1,000, 10,000, 1 million, something like that. All you're doing for metric conversions is moving the decimal either left or right, and you just count how many spaces you're moving. So it should be pretty straightforward. Okay. So here's that chart one more time, just in case you didn't get it. Again, kilo, there's 1,000 kilos in 1 base unit. We don't often use hecto or deca or deci, really, but centi, milli. I might throw these on your homework just because. So hecto is 100, deca is 10. The base unit is either meters, grams, liters, whatever you're looking at. Deci is 1/10. So there are 10 of these things in 1 base unit, whereas here there's 10 base units in one of those things. There are 100 centis in 1 meter, and then there are 1,000 millimeters in 1 meter. Okay, so I just want to talk about this graphic really quick. I pulled this offline. I should probably tell you where I got it. That would be the responsible thing to do. I don't know. You can probably Google it, but also you'll notice this silly. It's because underneath this silly, there's a word that's not a nice word, so I replaced it with a nicer one. So let's talk about why do we use metric, right? Because some people are like, Mr. Barton, this is kind of whack. I already know feet and inches. Why can't we just use feet and inches? I'm familiar. I understand how big they are. Why can't we use those? Let's talk about it. It's because it makes converting way easier if we use metric. We're just multiplying and dividing by tens, right? Whereas if we want to go from inches to feet, there's 12. If you want to go from feet to the next biggest thing, yards, there's 3. Then if you want to go to the next biggest, yards to miles, there's 1,760, because why not? And then if you want to do something with like weight, there are 16 ounces in a pound, right? None of these are nice units. Like why are there 12 inches in a foot? Who decided that? Did they measure someone's literal foot and go, well, if your toe's an inch long, your whole foot is 12 toes long? Like what? I don't understand where inches and feet come from. You could probably look it up, but it's whack. I saw this once on I don't know where I saw it, but watch this handy doodle when you look at conversions. If you pretend that this is like a wrist and it kind of flares out. You see what happens when you try and use American units? It's so dumb. It's rude, to be quite honest. Same thing with Fahrenheit. Why does water freeze at 32 and then boil at 212? And this is 180 units apart? And why do we write dates as month, day, year? It's not like smallest, biggest, like smallest, medium, biggest, right? That doesn't make sense. Here's how everyone else in the world does stuff. There's 1,000 millimeters in a meter. There's 1,000 meters in a kilometer. There's 1,000 grams in a kilogram. There's 1,000 kilograms in a ton. In Celsius, water freezes at 0 and boils at 100 and is 100 apart. Everyone else in the world writes dates day, month, year. It's so much better. The United States is silly, you guys. Anyway, I'll get off my soapbox. Thank you for making it all the way to the end of the video. If you have questions about unit analysis, how to multiply or divide units, how to convert units, please go ahead and hop in the WebEx and ask me. Otherwise, have a wonderful rest of your day, and I will see you guys later.